Okay, the second part of chapter 7. We are going to work on quantum numbers, and I want you to try to work on as many examples as possible on this. It might seem a little bit complicated at the beginning, but let's start working and I explain each one by one. Basically, what are quantum numbers and why do we have to study them is that just like any of us that we have a physical address to show our location, quantum numbers show the location of electrons inside the atom. For us, we have a house number or apartment number, we have a street name, we have zip code, we have the city and state. And all of these quantum numbers are the same as our address. They are trying to find out or locate the electrons inside the atom as much as possible or as accurately as possible. So there are 4 quantum numbers. You already know 2 of them, but you didn't know them under this name. So out of 4, you knew 2 of them so far. Let's start. Principal quantum number, which is shown in N, you remember, you call it energy level. Angular momentum quantum number, you show it in L, lowercase l. Magnetic quantum number, or ML. And finally, spin quantum number, MS. Are you ready? I'm going to work on each of these, and I will give you the examples. First one. Principal quantum number, which we show in N, it shows the distance of electrons from the nucleus, which we call energy level, right? The first energy level is closer to the nucleus, and by increasing the number of N, we get farther from the nucleus. That's all you need to know, and you know that there is no 0th energy level. N starts from 1 and goes higher. And do you remember in the previous chapter, we worked on 4 of them, right? When we were writing the electron configurations and learning the facts about energy levels and orbitals. So that's all about principal quantum number. You don't need to calculate anything for it. The second quantum number is called angular momentum quantum number, or L. This is what you know as orbitals. They show the space, angular momentum quantum number shows the shape of the space where electrons travel. You remember we said S is a spherical, P is dumbbell-shaped or two-looped or figure 8, and for D and F I told you there are more complicated shapes. For a given N, you always need to know N to be able to find out L. The possible quantum number L always starts from 1 less than N. So N and L can never be the same. For example, if N is 2, L cannot be 2. So possible quantities for L: N minus 1, N minus 2. You keep subtracting until you get to 0. So 0 is the minimum possible quantity for L. For example, let's do a simple example here. Let's say N is 2. So L must start from N minus 1, right? N minus 1 is 2 minus 1, which is 1. Also, we haven't reached 0 yet, right? N minus 2 is what? 2 minus 2, 0. You hit 0, stop. I want you to memorize something else at this point. We said L shows the orbitals, right? There are some numbers assigned to each of the orbitals. Which orbitals did we have? S, P, D, F, right? We're still working on this 4. S, P, D, F. The assigned L for each of the orbitals is, for S is 0, for L is 1, for D is 2, and for F is 3. So SPDF 0, 1, 2, 3. I want you to memorize it. So when we say N is 2 and possibilities for L are 1 and 0, what is the assigned letter for 0? We're talking about S orbital. And for L1, we're talking about P orbital. If you remember from previous chapter, from chapter 8, didn't we say in each level there are the same number of sublevels? Do you remember the table? So in the second energy level, you expect to have 2 sublevels, right? And we said that there are S and P. Now you found S and P by calculations. I told you, you know N and L, right? So the same orbital and labels and everything we have, now we are trying to find them by calculations, by very simple calculations. All right? I hope it was clear. Let's move on to the rest of the quantum numbers. The third quantum number is called magnetic quantum number, or ML. Magnetic quantum number shows the orientation of electron movement. Do you remember I told you for p orbitals we had px, py, and pz? Do you remember I told you that? Now we are going to find out those 3 orientations. Or I told you for s orbital, spherical, just one possibility, right? So for ml values, we have to start from minus L because we have L. For these are in the sequence. You start from N, you will find L, then after you find L, you will find ML. So for a given L, ML values are minus L plus 1, minus L plus 2, until you reach to the same number of L. We definitely need an example here. All right, pay attention. Let's say I'm talking about L1, okay? Possible values for L. ML starts from minus L. Minus L is what? Minus 1, right? Minus L plus 1 is what? Minus L plus 1 is 0 here because L is 1. And minus L plus 2 is positive 1. I told you to stop when you have the same L, right? Don't I have the same L? So I stop. What was the assigned orbital for L1? Previous slide. When L is 1, what is assigned orbital? P, right? We're talking about p orbitals. How many possibilities did we say we have for p orbital? 3, right? Do you see these 3 possibilities? Right? I told you, whatever we learned before, now we're going to find them by calculations. So you said 3 possibilities along x, along y, and along z axis, x, y, and z. Now, along x, y, and z. It's interesting how you can find it with calculations. If you want a formula here, ML is 2L plus 1. Here, L was 1, right? 2 times 1, 2, plus 1, 3 possibilities of ML. If you're a type of formula person, okay? Let's move on to the last quantum number, which does not need a calculation, and we already talked about it last time. We said in each orbital, there must be 2 electrons with opposite spin, right? So the last one is about spin quantum number, or we show it as MS. It shows the 2 possible spins of electrons. We said one of them is clockwise and one of them is counterclockwise. The signs that are assigned for clockwise is positive 1/2, and the sign for counterclockwise is negative 1/2. Two electrons, each one is assigned half of the spin. One is clockwise, another one is counterclockwise. One of them is assigned positive 1/2, the other one negative 1/2, so the total is going to be 1. So you can show it as ms is positive 1/2 or negative 1/2, or you can put them together. No one knows which electron is spinning in which direction. We just assume that one of them is clockwise, another one is counterclockwise. And so you can assign any of these. All right? Ready to work on some examples? There are totally 3 types of questions that you can have for quantum numbers, and I'm going to work on all of them with you. First, a very general question. Find quantum numbers of an electron in the second energy level. When we say second energy level, what is 2? N. N is 2. Let's try to find L, ML, MS. So, for a given N, possibilities for S is N minus 1, which is 1, N minus 2, which is 0, right? So, what was the assigned letter for N1, L1, P, and assigned letter for L0 was S. So we are talking about S and P orbitals, right? Need to find ML for both. L, let's put it here, 0. ML is from minus L to positive L, right? Minus 0 and positive 0 is always 0, right? So ML is 0. Don't forget, ML shows the possibilities, and we said L0 s orbital is just one sphere, one possibility for the shape. A sphere is always a sphere. So that shows one possibility. When L is 1, we're talking about p orbitals. When L is 1, ML is minus L, which is minus 1, minus L plus 1, which is 0, and minus L plus 2 at this point is positive 1. And we said to stop whenever you have the same number for L. So we said for p orbitals, we have 3 possibilities. We are showing these 3 possibilities. And finally, MS, we don't know. It can be either positive 1/2 or negative 1/2. So this is how you can work on a very general question about quantum numbers. When an electron is in the second energy level, we say we don't know. Electron might be in s orbital or might be in the p orbital. If it is in s orbital, there is just one possibility to travel inside the sphere. If it's in the p orbital, then it can be along the x-axis, y-axis, or z-axis. And it can spin clockwise or counterclockwise. So we're trying to locate that electron as much as we can. The second type of questions you get is a little bit more specific. Chlorine is given, determine quantum numbers for the last electron in chlorine. When we are determining for an electron in a certain atom, you better write the electron configuration and draw the orbital diagram. For the very last one, so just draw it for the very last one. How many p orbitals did we have? 3. So how many boxes do we need to draw? 3, right? How many electrons do we need to put in these p orbitals? 5. 1, 2, 3, 4, and 5. Don't forget you need to fill them with 1 electron first and then go back and fill completely paired electrons. So we are talking about this last electron. Here you're lucky because you can determine N and L, and you don't need to you don't need to do any calculations. Where is the electron? In the third energy level. Do you see it? So N is 3. In which orbital did you find electron? In P, right? What is the assigned L for P? Wasn't it 1? So you already know N was 3, L is 1. You just need to calculate ML. ML values are minus L, which is minus 1, minus L plus 1, which is 0, minus L plus 2, which is 1. You have this positive 1, so stop. And you say MS is always either positive or negative half. You don't know if it's spinning clockwise or counterclockwise, but it's either of them. And the last one is we give you some sets of quantum numbers. You're supposed to find the possible or impossible quantum numbers. So let's see if we need to reject any of these or accept them. Working with the first set. N, when N is 4, L is 4 here. We said N can never be the same as L, right? So it's not permissible. Second one, when N is 3, L is 2. Yes, L can be 1 less than N. ML values, if you calculate it for L2, you have different ML values, and ML1 is one of them, yes. And MS, we said either positive 1/2 or negative 1/2. So this is permissible. The third set, when N is 2, you calculate N. L is 1 and 0, yes, correct so far. ML is correct so far when you just put all of these in the calculations. But MS cannot be anything except positive and negative 1/2, so it is not permissible. And finally, the last one, when N is 5, I can't calculate the last one for you. When N is 5, possibilities for L are 4, 3, 2, 1, and 0. N minus 1, N minus 2, N minus 3 until you reach to 0. So this L is one of them, correct. When L is 3, possibilities for ML are minus L plus 1, minus L plus 2. You keep going until you have the same number. This ML negative 3 is one of them. Yes, all of them are correct, and MS can be either positive or negative half. So this is another permissible answer. So these are the maximum possibilities for the questions you get about the quantum numbers. Please feel free to ask me if you have any questions when we have the class together.